All right, in this lesson, we're going to be looking at other ways to analyze a linear function and talk about how we know things are linear and what other things we can do with them. So this one, the sophomore class decides to put on a dunking booth. You throw a ball, hits it, teacher drops in the water, everybody laughs at him. The cost is going to be $150 to rent it for the day. They're going to charge each student 75 cents. So hopefully in your head, you're thinking, this is where we're starting. This is changing. This is our B. This is our M. If you're thinking that way, you're on the right track. How do we know it's linear? It's a constant rate of increase. And in this case, 75 cents per throw. Because that's constant, we know that it's linear. Now the next now rule just tells us how do we get to the next amount? We just take what we have now and we're going to add 75 cents. And that's all the next now rule is. And it's a lot of times how you're thinking is I make 75 cents for one, $1.50 for two, $2.25 for three, and so on. That's all the next now rule is. We will look at this, we'll be using this a little bit more as we go forward in the unit. And write a function rule. So the profit, in this case, again, we're going to start with 100. We're going to start actually down $150 because we spent that much money, but we're going to make 75 cents per throw. Now it says T purchase, so really I should use the variable T right here. If you used Y and X, that's okay. Just understand what Y and X are for. So my profit is going to be 75 cents for every one that is purchased. And again, this is negative, and it's important to understand that this is negative because I had to spend the $150 first. So how do I make a profit? Really, the question is, how do I make $150? Well, if we have to make $150 and we make 75 cents per throw, there's a couple of ways to do this, but one very kind of simple way is just divide 150 by 75 cents. If you use a calculator, it would be 200 throws. And that's what we would do to break even, or 201 throws to make a profit. You could also put that into this equation. You could put your profit into this equation is equal to 0, or $1, or whatever you want to put in there, just a little bit, minus 150. And then when you solve this, by adding 150 to both sides, you get 0.75t equals 150. And then again, when you divide, you're going to get t is 200, which is the same thing you did here. So you didn't have to use the equation to solve it. This is if you wanted to. If you did this, that would be perfectly acceptable in any test or practice that you take for this course. Let's look at a sequence of numbers now and just look at it in a slightly different way. This one here, if you see the way it's written, this next now rule should be easy because it's set up as an next now. So how are we getting to the next number? Well, we're going from 1 to 5 to 9 to 13. So we're just taking the number that we have now and adding 4. The function rule for this situation, a little bit more tricky, but not really that difficult. 1, 2, 3, 4. So the first number is a 1, the second number is a 5, the 9, and 13. Well, if you go back and remember what we've been talking about, one of the first things you really should want to do is say, well, where did it start? 4, 3, 2, 1, 0. Where did we start? Well, subtract 4, and there you go. So we know in our y equals mx plus b, where this is where it starts, and that's how it changes. We know that it starts at -3. But we also know it's going up 4 every one. So our slope is going to be 4. And there's your function rule. There's your next now rule. And that's how you can do it if you're given a sequence of numbers.